How's it going, everyone? Today we're going to go over how to receive money on a Bitcoin address, and we're actually going to generate that address. So this is going to be the first out of a couple of tutorials on how to work with Bitcoin wallets. So the first thing we want to do is we're going to clear the screen, and then we're going to create a new Bitcoin wallet. Now, it's important to say that you're going to have Rust installed, and there's a bunch of tutorials that go over how to install Rust. So we'll call this Bitcoin wallet. We'll go inside this directory, and then we can open up VS Code. Now I have the Bitcoin analyzer, and I also have some Rust extensions installed. Those should be pretty easy to find. You can just Google them. So we'll move on. So the first thing we want to do is we want to get our dependencies. So the first dependency that we're going to use is we're going to use this. We're going to use the Rust Bitcoin dependency. So we're going to copy this. At the time of writing this, they are on. So the latest crate version is 0.27. The newest version, they haven't. That's really not out on the crate repository. So we're just going to use this GitHub link. So it's going to be Bitcoin. And we're going to use a dependency. We're going to enable the RAN dependency that comes with the Bitcoin Rust feature, or that comes with the Rust Bitcoin. Perfect. Now in this main here, we can, well, actually, let's we'll create a new file, and we'll call it Bitcoin client. Okay, and then in our main, we can just import our Bitcoin client. So we'll perfect. We'll just import our Bitcoin client, and then in our main, what we're going to do is we'll first create a method. We'll just say, since this tutorial will be just generating a Bitcoin wallet, we're just going to say pub function generate wallet. Okay. Now, so we have to, there's a couple things we have to do. So let's go over the list of steps that we have to do in order to generate this Bitcoin wallet. So first, we're going to have to create a master node, right? So the way this works is you create a master node first, then you create a purpose. You're going to drive a purpose node. In our purpose node, our purpose node it's going to be our Bitcoin address format. So it'll be something like pay to public key hash, or pay to witness public key hash, or pay to script hash or pay to Taproot, right? So that's going to be the next step. Then the next step is we'll have to get a coin type. So so this is going to be like, do we want this address that we're going to generate? Do we want this to be on testnet, mainnet, regnet? So we'll have to pick something like that. And then the next step is we'll have to actually generate a receive address. So we can actually generate multiple receive addresses. So yeah, we'll have to generate a receive address. So the first part is we'll generate a master node. So let's use the SPC 256 K1. This is going to be use okay, so so I just the spelling was wrong here. So we generated this. This is basically just a like a function or like a scalar on the elliptical curve. So this is our like elliptic curve function. So basically what's happening here is we have this generator point, x and y, and we can use our generator point is calculated like this, x to the third plus b mod s. So what's happening is this function here is going to generate our y, x, and b, because there's certain numbers that there's certain values that Bitcoin uses for its elliptic curve, and then that's the key size. Okay, and that's the key size. So we can get our public key. So this is just our generator point, but we can actually calculate our public key by using our generator point and then picking some random points for x and y, and then multiplying them by our private key. So we're using our private key to derive our public key, and this isn't typical multiplication. This is actually this is scalar multiplication. So you're actually going to use something called point doubling, and a bunch of tutorials online, so we won't go into that. So the next thing is let's pick our network. Let's do the network. So let's pick our network first. Okay, so now we have our network, and I think I'm missing the actually Rust analyzer. I thought I had it installed, but Rust analyzer. perfect. So now that we have our network, so this is just an enum with that can either be testnet, mainnet, or our RegNet. So we'll specify that a little bit later. Now we're going to generate a random number. So the way we can do this is we can have our secret key. We can have our secret key and our public key equal this elliptic curve function, which will generate which will use a mutable random thread. Now that we have this Rust installer, hopefully, yep, now we have the auto import. And we just have to save. Okay, perfect. So what's going on here? So this is just us generating. Oops. A random point. So that's just us generating a random point. The next thing on our list. So the next thing on our list is we're going to create a new public key from a Schnorr pair. So we're going to, there's a thing in Bitcoin, they're called it's like Schnorr signatures. So we can actually derive a key pair. We can use the Schnorr signature to derive a key pair. Or signature, or we're going to use this key pair. Great. All right. So now that we have that, we can pass in our elliptic curve function. Right, and this has our curve and some points, some randomly generated points, and some of the important points that we need for Bitcoin. And then we'll take our secret key, and what's going on here? And we can get our we can get our key pair. So now that we have this key pair, actually, before I do that, let me kind of write what we did here. Okay. Public key pair from the Schnorr. Okay, so we derived it from the Schnorr algorithm. The next step is we're going to there's a thing, it's called we'll first, so we need to tweak our public key so it works with so it can work with Taproot. And Taproot is like Bitcoin's new upgrade. So we're going to tweak our public key so it works with Taproot. key pair. And we're going to reference our previous our key pair over there. Next, we're going to derive a taproot address. So right, and this could be we could even derive like a pay to public key hash. So this is what we're doing up here. We're deriving a purpose address. So like a pay to public key address, pay to public hash, pay to script hash, or pay to taproot. So just because taproot's kind of the newest thing, we'll just derive a taproot address. And what's going on here? And we're going to use the utils. So we're going to choose taproot, and we'll take our elliptic curve function. We'll take our elliptic curve function. Next, we'll take our public key that only X knows. So only X knows this public key. Then we'll take for the root node. We don't need anything for that. Perfect. Now let's also generate a. Just missing a D there, but let's also generate a pay to let's do a pay to witness public key hash address. Let's do that one. So we can do pay to key hash. Okay, we're going to take our public key, and we actually need to derive a public key in another form, right? Because the public key that we're using isn't using. See, it's not using. What's the error? Yeah, it's not using the correct public key. So let's do that. So we're gonna make this a reference to our public key. New. And then we're going to send in our public key. Now this is going to derive a pay to witness public key hash. Okay, so now just so we can see what it's the difference between we can see the difference between a taproot address and a pay to witness public key address. You can also obviously there's a lot of other address formats. Just a rule of thumb: the newer Bitcoin addresses are typically going to be cheaper to send and receive funds from. So that's something to keep in mind if you are programming a Bitcoin wallet. This is not conventional, so let's fix this. Okay, perfect. Now for the last part. So at this point, we have our address. We have our Taproot address, and then we have our pay to witness public key address. So let's print them out. Let's do pay to so this is going to return a, let's see what this returns. It returns a result, so we need to say, we need to convert this to an optional. Oops. You have to excuse me, I just learned Rust, so yeah, I'm relatively new to Rust. And then we'll just do lowercase. Perfect. And for the next one, let's do print line. And now let's print out our pay to Taproot address and see what that looks like. Perfect. Let's see the final result. Cross your fingers. Hopefully everything turns out well. And my plan for, let's see, we need to actually import our public key client. So Bitcoin public key client. And my plan is we'll probably have like a generate wallet. So this is generating a new wallet. Then we can also do like a import and an export wallet as well. Check that out. We have a pay to public key hash. So this is actually payable. You can actually send Bitcoin to this hash. And this is a pay to Taproot hash. So let's see, I believe we're using, yeah, this is the actual Bitcoin network. So since we're actually just doing development, we should use testnet. Okay, perfect. Okay, now let's just check and make sure that these are actual Bitcoin addresses. So we can copy these addresses. And we can go to a block explorer. Now we can paste that into our block explorer. And we see it's a BEC32 Bitcoin address. So this is a payable Bitcoin address on testnet. Now if we took the other one, we would have went on mainnet. Now let's check, let's just confirm that this is a Taproot address. So I found a weird thing. I guess for some reason when you put it in there, it won't find it for some reason. But if you instead just put it in the URL, you can see that this is an actual Taproot address that you can pay to. So hope you guys enjoyed that. If there's other things you'd like me to talk about, or if you have ideas of ways I could improve, please let me know. Also, if you're feeling generous, I'd greatly appreciate it. This would just allow me to focus more on doing the things that I love and teaching people more about cryptocurrencies and some of the cool, amazing things going on there. Thanks so much. I hope I save you guys some time and energy, because I know that this stuff can be kind of tricky and kind of confusing when you first learn it. So I think the next step will probably be to maybe we could check the on-chain balance and we could actually connect to the Bitcoin network. So take care.